Okay, you said 4, 5, 6, right? Okay, so is it continuous from here to here? So now the bracket means that it's going to be equal to, right? Now, so think of it like this. So we know that secant is the reciprocal of cosine, right? So it's the reciprocal of cosine. So I'm just going to do it like this. I'm going to rewrite it as 1 over cosine x. All right? So let's take a look. Pi over 2. So at a negative pi over 2 on my unit circle is actually going to be all the way down here, right? It's going to be right there. So what is the x value right there? That's going to be 0, right? So that's going to be 0. So because of this, this is going to be 0 in the denominator. So it's going to be 1 over 0. Am I allowed to have 1 over 0? No, because this is a bracket right here, that means no, because it's equal to there. But let's look at everything else. I'm going to look at it because on number 5, it talks about the same thing, but as a parentheses. So now, so it is 0 here, and it is also 0 right there. So, is there any place going from here up to here on my unit circle, so from negative pi over 2 to positive pi over 2, in which that cosine is also 0? No, because right here it starts at 0, right? 0, and it goes positive, 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 and it goes to the number 1. So right here, this is 1, right? And so from there, it also starts going down, 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 back to 0 right there. So it's 0 here, and it's 0 here. So every place in there also exists. Every place in between exists. So that means that I can have it, it is continuous on the open interval here. On the closed interval, no it is not. So yes, it is continuous here on this one, but not on this one. Okay, and what was the other one? 4, 5, 6? 6? Okay. All right, so let's plug it in, see what we get. So at 4, that's going to be 4 squared, 16 times 3 is 48. 48 minus 44 is 4, minus 4 is negative 8. You guys please check my math, because I just like, you got 0? Okay. 4 minus 4? Okay, yeah, 0. Okay. See, listen, come on now, I'm rolling through this. So it's 0. So it was 4 minus 4? Yeah, because it was positive. Sorry. Okay, so now let's look at the other one. So this other one says that this has to equal for this to be continuous. That means it has to be continuous. It must be continuous. It absolutely must be continuous. So this bottom one has to be equal to what? 0. Because the left side, it has to equal the right side. So if this is 0, that means the bottom also has to go to 0. So I'm going to set it up as 0 equals, now, k squared, or I'm sorry, k times x squared, so that's going to be 16k, right? Yes? 16k minus 8 minus 1. Huh? Okay, speak. Oh, then speak so I can understand and help you with your confusion.
No, I was confused as to why you were putting x is equal to 4. Like you're plugging in 4 for x.
Yeah, plugging in 4 because both of these have to be 4, right? So the limit as this goes to 4, for this, the left hand and the right hand both have to, approach 4. We're just, so as the top goes to 4, it's going to 0. But as the right goes to 4, I'm setting it equal to 0 because that's what it has to become. So if this has to become this is negative 9, right? Negative 9, and then positive 9. So 9 equals 16k. So k equals 9 over 16. So we found the value for k for this to actually become 0. So these are ones that I guarantee you will have this on there. You will see many of these problems where you're going to have to make it, find some variable that will make it equal, make it continuous. Does that make sense? Better? You're zoning out. Yes?
Yes.
Are you happy? And you know it? Clap your hands. There we go. All right. It's only 2 claps, not 3 claps. Some people. All right. Okay, so everyone good with the rest of those?
We did not get to do it.
I didn't even see.
You didn't get to do them? Okay. Oh, some people were out on the phone while we had those 10-minute break. Okay, it's all right. It's all right. Okay.
I will finish them.
Yeah. Hey, don't blame me because you were on the phone.
Oh, no,
Okay.
I was on the phone. What about the rest?
Huh?
Yeah, I didn't see it.
I know you're looking for coffee, right?
No.
It's a. I'm sorry. Okay, 10-minute breaks. The all I could afford for this. Okay. So, otherwise we're gonna stay here until like 4 o'clock today. You guys want to stay till 4?
No.
No, I don't either. Okay, no offense. This is my break too. Okay, so I was supposed to adjust this before I started, but anyway. Okay.
Lights, camera,
Oh,
action.
no, it's already recording. I recorded the practice part. Okay. All right, so deriving the formula. So whenever we're doing this, slope, snap. Okay, right here, slope, 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 slope. Derivatives, slope. Derivative is the slope, right? Slope. It's the rate of change. It is a slope. It is the rise of run. It is a slope. So every time I'm talking about this, it's find the slope. Slope, slope, slope. Slope, slope. The whole point of calculus, doing derivatives, it's always a slope.
What?
Slope.
Oh, the slope.
The slope. It's a slope. Okay. All right. So, rise over run. Ah. This thing doesn't love me no more. All right.
It's 'cause we're on break.
Yeah, it wants a break too.
Yeah.
You're on a break. What is this?
We're on a break.
Anyway, oh, the calculator was messing up. That's why. You're always on break. Just need to find you one of these days that you're not on a break. When I scanned all these in for the PDF, the scanner decided that it wanted it upside down. I'm like, okay, I see there's a problem there. But then when I load it into this, it doesn't like being upside down. So for those people that are, took a 25-minute break because they were on the phone, you could actually use this last couple minutes to, maybe look at some of those other problems. But it's all right. It's all right. Okay, so there we go. All right, hopefully that works better now. All right, so like I said, this is always going to be the slope. Everything that we're dealing with for calculus is a slope. Rise of run is a slope. And then we have at a curve. So now, this is one of the items in which that we are going to talk about all the time. So you just need to know the difference on here. So if I find the slope in between 2 points over here on a curve, okay, on a curve, this is called the secant line. The secant line touches at 2 points. The secant line touches at 2 points. The tangent line, only 1 point. So, big difference there. Secant line is going to be 2 points, where tangent line is 1 point. Okay? So, all right, formula. Right here, this is super important. This is probably the difference quotient. You'll see this quite often. Right here, f of x plus h minus f of x all over h. So, we plug it into our function, my difference quotient, and give me a problem so I can actually do this. Trying to get down to there. Where was the problem? I missed it? Oh, there it is. There it is. Okay. So, here it is. So, I have those values. So, if I plug it into this, so every place I see x, I'm going to put x plus h. So, x plus h squared minus f of x, which is just my function, which is x squared, all over h. And now, at this point in your mathematical career, you should be able to do this without actually having to do all your FOIL. So if you were to do this, it would be x squared, right? Now, it's going to be plus 2xh, right? It's 2 times these two multiplied together. So it's going to be 2xh plus h squared minus x squared all over h. And now from here, what can I do? I can cancel out my x squareds, right? Cancel out the x squareds, and I'm left with 2xh plus h squared all over h. And they have a common factor. Every time you do this, it will cancel out so you can factor out your h. That's the whole point of all this, is canceling out the h. So as you do this, I'm going to take out an x, take out an h, and I'm left with 2x plus h all over h. And so now I could cancel out my h, right? I could cancel out my h because I'm taking the limit as h goes to 0. Okay? So now that I canceled out my 0, or my h, right? I canceled out my h. Now can I plug in 0? Say yes. So my answer is going to be just 2x. Now, what did I just come up with because of that? That's the what? That is the slope, right? At any. So that's going to be f prime of x is 2x. So that means that's going to give me the slope at any point. What is my point that I'm dealing with here now? 2, 4. Okay, so I'm going to plug it in. So my slope 2, 4. So let's see if I plug that in. So I plug in 2 for my x value here. So that my m value is 4, isn't it? Now, I'm going to make an equation of a line. Find the slope of the curve here. Oh, I don't need it. Okay, I already got the slope. That's all I need. I thought I needed an equation. So, find the slope. So my my slope is 4. Yes?
I just realized something.
Yes.
That when we were talking about derivatives, if you do that, you also get that.
Yeah.
And then you plug it in, and then you get 4.
Mm-hmm. So yes, the f prime of x squared is just going to be 2x. So it's a longer method using algebra to get the derivative, but now we have, okay, this is the algebra, but now we have the derivative of the derivative. right there. We came up with 4. Long process. Oh, here's another one. No, I don't want to do that. Where's that next one? There's supposed to be another one. I don't like that one. Okay, so differentiability. Okay, someone asked me this question on the test. They're like, hey, what is this? What is this word? And I was like, can you take a derivative?
I asked it twice.
Huh?
I asked it twice.
Okay, you could ask. I wasn't throwing you under the bus on that one, but still. Okay, so remember, the derivative is the slope. It is the slope. So if I'm looking at this, and in this case right here, it's going to be a pointy point, isn't it? It's going to a pointy point. So now the slope right here is a positive, but the slope over here is a negative. But in between there, it doesn't go to 0. So what is allowed if it was to go like this and there? Here's positive on this side. Here's negative on this side. But right here, it has to go to 0 first. Because we can't balance on a pointy point. So on the tip of a needle, you don't know what the slope is on the tip of a needle, right? Yes? That's the point. Okay? At the tip of the needle, you cannot. So this is what we called a cusp. So because it's changing from a positive to a negative without gradually going to 0 first, yes?
Was that pun intended or no?
Pointy point?
No, you said,
That's the point?
yeah. Was that intended?
This is important.
You know, like everything I talk about all the time, everything's a pun. So if you sit and think about it, yeah. Almost all the time there is a pun in just about everything I say. It just depends on if you get it or not.
It's just the dad and
I know, right? There's the dad joke. Yeah, dad vibe. See, now, just to let you know, this joke was recycled from the last chapter. But you didn't get the point then, but you got it now. Okay, anyway. Where's the problem I was looking for? Nope. Don't want to do it. Nope.
I wish I could do that, but no, I don't want to.
Nope. Okay, here's the one. All right, so for this one right here, it's almost like I gave you this one on a test. Okay, so I would go over this one. So now, using my function, right, it would be f of x plus h, right? So, but I'm going to write my radical as a fraction, a fractional exponent, because I hate radicals. I really do. I just write it as a fraction instead. It works out better, and later on, I don't know, I'm just weird. Okay, anyway, so we have x plus h to the 1/2, right? So that's this right here. So every place I have an x, I put x plus h, minus f of x, which is just going to be my x to the 1/2, all over h. Now, so we have a problem because I cannot take anything out. I can't expand it 1/2 times, can I? No, if it was a square, I could expand it, right? But I cannot expand it 1/2 times. So that's the piece that's going to be key to actually getting this piece right. So, now, this right here, I need the Jerry Maguire of math. That's an old meme.
I doubt it's even a meme.
Seriously, it is. You complete me. Anyway, all right. So, to complete this one right here, it is 1/2, right? So how much more do I need to complete it? Okay, I need another half, right? So I need 2 of these, right? I need 2 of these. So now what I'm going to do here, I'm going to multiply by the conjugate because I'm going to have 2 of them. And when I multiply them together, it completes it. It makes it one whole. So I'm going to have I'm going to bring it down here. So it's x plus h 1 half minus x 1 half over h times, now the conjugate, remember the conjugate is different signs. It's the same thing but different signs, right? So that would be my x plus h 1 half, and this is going to be a plus sign, x to the 1 half over, same thing, x plus h 1 half. So I'm multiplying by the value of 1, but my value of 1 is just ugly. U-G-L-Y, it ain't got no alibi. You sleeping again. Seriously, I'm worried you're going to get like whiplash, bro. Seriously, you're doing like the head bob thing. Yeah. All right, so right here, it is ugly, but it is still 1. It's still a value of 1 because everything on top and everything on bottom are the same. So it is 1. So when I distribute this, and I go through and distribute this, I'm going to change it blue. All right, just because I feel like it. All right. So for when I distribute this, this is going to be the difference of 2 squares. So when I multiply this times this, it's going to complete it. So it's going to be these squared. So it's going to be just x plus h. Right? And so there's my first one. So I'm going to do the whole thing out so you guys can see this. So there's my first one. And then my second one is going to be plus x 1 half, x plus h 1 half. And then when I do this one here, it's going to be minus x 1 half, x plus h 1 half. And then my last one is going to be a negative and a positive, x squared times x, x to the 1 half times x to the 1 half. I add the exponents, it's just going to give me a negative x. And I'm going to leave the bottom all factored out. I'm not going to multiply it together because, you know, it just sucks like that. I don't want to do all that math. I don't. I really don't. All right, so h quantity of x plus h 1 half plus x 1 half right there. So it's all there. But now my middle terms right here, those terms right there in the middle, those are going to go away. Those ones go away, so I'm left with this one here, and this one here. So that's what happens when I multiply by difference of squares. My middle term always cancel out. So I'm left with a x plus h minus x over h quantity x plus h to the 1 half plus x to the 1 half. So now on top, what's going to happen to my x's there? Those cancel out. The x's go away, but they're still left with an h, right? So there's still the h's. So the h and the h will also cancel out here. So I'm going to have, let me see, doing the math. So it was h over h quantity x plus h 1 half plus x to the 1 half. So those will cancel, so I'm left with just 1 on top. Now, the h that was multiplying, that would actually make the whole thing 0. I've canceled that out. So I couldn't plug in 0. So now I can, the limit as h goes to 0. So now, since those are gone, I can now plug in 0. 0 plus x is x, right? So it's going to be x to the 1 half plus x to the 1 half. So how many x to the 1 halves do I have? 2. I have 2 of them. So it would be 2x to the 1 half. Yes? No? Maybe? So the process, this is by the limit process, but let's do the derivative process because we already know this one, right? So it is, let's say f of x is x 1 half. Okay, what do I do with my exponent? Goes out front, doesn't it? And then I subtract 1. So if I do that, that's going to give me 1 half x. So if I subtract 1, that would be negative 1 half, wouldn't it? So negative 1 half and then rewrite it so that the positive exponent, this moves to the denominator, so I'm left with 1 over 2x 1/2. So, doing it the algebra way or the derivative way works out. They always do.
If it doesn't, then that's not good.
Yeah, then there was most likely an algebra mistake. So the derivative is quite simple, isn't it? So now that you know the derivative process, you don't want to do the algebra anymore, do you? Okay, so majority of all these problems that we're going to do is you're going to have something awkward that you cannot just take a derivative of. So all the problems that you're going to see, you're not going to be able to just do the derivative. You're going to be given some weird function that's going to look like this, and you're going to have to figure it out. Okay? It's not going to be easy. Just go through and jump to the derivative. All right, let's see where are we at. Okay. All right. So now here's our practice problems here. So let's go ahead and 10 minutes. Okay. Don't forget, like, share, and subscribe.